Hello everyone, welcome to ncert tutorials. In this video, we will learn about linear equations in one variable. Before going to learn about linear equations in one variable, once try to recall algebraic expressions which we discussed in our previous classes. What is an algebraic expression? In maths, along with numbers, we use letters also. These letters we are calling as variables. So, along with the numbers, if I use letters like X, Y, Z or A, B, C, so these letters we are calling as variables. Variables. Along with numbers, if we use letters, then these expressions, here in this expression we can use addition or subtraction. So this expression we are calling as algebraic expression. So if this expression has an equality, that means for this expression, if we equal this expression to any quantity or any variable, here it may be any number or any variable. If the expression has an equal quantity, then this expression becomes an equation. Now this we are calling as equation. So in this equation, we have two variables. What are that? We have x and we have y, two variables we have. So linear equations are nothing but if the equation have the degree 1, then that equation we are calling as linear equation. What is the degree? The variable power we are calling as degree. Suppose I have variable y and here the power is 2. So this variable power whatever is there, that we are calling as a degree of the expression. Suppose see some examples. 3xy plus z cube plus 25 is an expression. If we equal this quantity to any number, then this becomes an equation. So without any equality symbol, we call this as expression. If there is any equal symbol, then we are calling that as an equation. Now in this equation, see here we have three terms. This is the first term, second term and third term. So what is the variable power in this first term? Here x power nothing is there, means 1 is there, and y power 1 is there. The total power, total variable power is 2. Now in this term, the variable power is 3. And here there is no variable, nothing is there, means we can write as x power 0, which is nothing but 1. So here the variable power is 0. So where we have the highest power, that we are considering as degree of this equation. So here for this equation the degree is 3. Like this, if any equation is there whose degree is 1, what is there in linear equations? A degree must be 1. And in one variable there must be only one variable in our expression. See some examples. Suppose I have 5z plus 2 is equal to 0. So here this equation's degree is 1. And here we have only one variable, that is z. So this expression or this equation we are calling as linear equation in one variable. See one more example. 3x plus 2 is equal to x minus 5. See here also we have only one variable x, in the both sides same variable we have. So in this total expression we have only one variable and this equation power is 1. So the degree is 1. So this equation also we are calling as linear equation in one variable. So now once again see, linear equation means the equation whose degree is 1 is called as linear equation. There are linear equations with two variables, linear equations in many variables also is there. See here 3x plus 5y is equal to 29. See in this we have two variables, degree is 1 only. So this expression, that this equation we are calling as linear equation in two variables. Okay. So now in this chapter we are discussing with linear equations in one variables only. Before going to solve the problems, see one important thing. See if you want to solve this equation, if any equation is like this, solution of equation is nothing but we need to find the value of x. Finding the value of variable is nothing but solution of that equation. So here my variable is x. I need to find the value of x from this equation. So for that I want only x. This 3 I don't want. So I am sending this 3 to the equal to opposite side. So here 3 is in left hand side of this equal to. Now I am sending this 3 to right hand side of this equal symbol. Now what we have? X only I have. X after is equal to, and then 7 I have, and this 3 I am sending to opposite side. So here before 3 no symbol is there. That means it is plus 3. Whenever we are sending a positive number to the RHS, it becomes minus. Now same like that, see the second expression example. See here also from this equation I want to find the value of x. So I need the value of x. That's why I am sending the remaining number to the RHS. So finally I have only x in LHS, and then is equal to after we have 7. Now this minus 3 I am sending to RHS. Whenever we are moving any term with negative sign from LHS to RHS, this negative sign will becomes positive. See what we did here? Whenever we are moving any term from LHS to RHS, if the term is a positive sign, then it becomes negative. If the term has negative sign, then it becomes positive. Now coming to multiplication and division. See here also, whenever we are sending any number from RHS to LHS or LHS to RHS, if the number is in multiplication, it becomes division when we are sending to opposite side. If you are sending any number from LHS to RHS, in LHS, if the number is in multiplication, then it becomes division when we are sending the number from LHS to RHS. Likewise, when you are sending any number from LHS to RHS, then the division becomes multiplication. What is that? The division becomes multiplication. See here, x divided by 3 is there. This 3 I am sending from LHS to RHS. So x is nothing but 7 into 3. Like this, the symbols will change when we send a number from LHS to RHS. These things we need to keep in mind before going to solve the problems. Now, see the first problem in exercise 2.1. See here, the first problem is x minus 2 is equal to 7. See, there are two ways to solve this problem. Now, see the two ways. Which one is easy for you? You can follow that. Now, see the first method. What is our problem? X minus 2 is equal to 7. We need to solve this. Solving is nothing but we need to find the value of x. Apart from x, which term we have here? Here we have minus 2. So for this, to make this minus 2 as 0, I need to add plus 2. So that plus 2 I need to add both the sides. So my target is I want only x in the LHS side. So for that, along with x, here I have minus 2. To make this as minus 0, for this minus 2 I am adding plus 2. So this plus 2, both the sides I am adding. Now minus 2 plus 2 will become 0, that is x minus 0 or x plus 0 is equal to 7 plus 2, 9. So x minus 0 or x plus 0 will become x only, x is equal to 9. Like this we will do in the first method. Now see the second method, how to solve the same problem. X minus 2 is equal to 7. As we discussed in the previous thing, I want only x in my LHS side. Along with x, here I have minus 2 also. So this minus 2 I need to send from LHS to RHS. So whenever we are sending a minus number from LHS to RHS, it becomes plus number, positive sign it gets. So that is nothing but x is equal to 7 plus 2, 9. Whichever is easy for you, you can follow that method. Next one, y plus 3 is equal to 10. So in y plus 3 is equal to 10, I want only y in the LHS side. So I am sending this plus 3 to RHS. Whenever we are sending a positive number, it becomes negative. So y is equal to 10 minus 3, which is nothing but 7. Now see the next one. See here, don't get confused. The variable is in RHS side. We know that A is equal to B is same as B is equal to A. Both are same only. Same like that, I am writing this problem as Z plus 2 is equal to 6. See the same numbers, only numbers I am not changing and variable also did not change and the place also I am not changing. Z plus 2 6, Z plus 2 6 only. Only LHS I was written as RHS and RHS I was written as LHS. That's the thing. Now I want only Z in this. So I am sending plus 2 to the opposite side. So whenever we are sending positive number it becomes minus. Now the Z is equal to 6 minus 2, 4. 3 by 7 plus x is equal to 17 by 7. So in 3 by 7 plus x is equal to 17 by 7, I want only x in LHS side. So x is equal to 17 by 7 and this 3 by 7 I am sending to opposite side. Before this 3 by 7 no symbol is there, means it has plus sign. So whenever we are sending a positive number from LHS to RHS, it becomes negative. So it becomes minus 3 by 7. So in rational numbers we learned how to do subtraction of equivalent rational numbers. So here the denominators are same. So simply we need to subtract numerators. 17 minus 3 by 7, which is nothing but 17 minus 3, 14 by 7. 7 ones, so 7 twos, so that is nothing but 2. So the x value here is 2. See the next one. 6x is equal to 12. So I want only x here. X is equal to this 6 I need to send it to RHS. 6 here, 6x means 6x is nothing but 6 into x. So whenever we are sending any number which is in multiplication, it goes to opposite side, it becomes division. So 12 divided by 6. So 6 ones, 6 twos, 12. So x is equal to 2 is the answer. The next one, t by 5 is equal to 10. See here the variable is t. Any letter may be the variable. So the problem is t by 5 is equal to 10. In this I want only t. T is equal to 10. See this 5 is in division. T divided by 5. This 5 is in division. Whenever we are sending this 5 from LHS to RHS, it becomes multiplication. So 10 into 5. So T is nothing but 50 is the solution for this problem. Now see the next one. 2x by 3 is equal to 18. See here 2x by 3 is nothing but 2 by 3 into x is equal to 18. So this also we can do in two ways. See the first one. 2x is equal to 18. See here the 3 is in denominator, means it is in division. Whenever we are sending this to opposite side, it becomes multiplication. Now I want only x value. X is equal to 18 into 3. See this 2 is in multiplication here. When we are sending this to opposite side, it becomes division. Now 2 ones, 2 nines, 18. So x is equal to 9 3s 27 is the answer. Otherwise, see here 2 by 3 is in multiplication. When we are sending this 2 by 3 to opposite side, it becomes division. So x is equal to 18 divided by 2 by 3. X is equal to 18. See in rational numbers we learned that how to do the division with rational number. Instead of doing division, we will do the multiplication with its reciprocal. 2 by 3's reciprocal is 3 by 2. So 2 ones, 2 nines. So finally x is equal to 9 3s 27. In these two ways, whichever is easy for you, you can follow that method. 1.6 is equal to y by 1.5. So for our convenience, I am writing this as y by 1.5 is equal to 1.6. So from this I want to find y value. So this 1.5 is in denominator. When we are sending this to opposite side, it becomes multiplication. So 1.6 into 1.5. So in decimals we learned that how to do the multiplication of decimals. So the y value here is 2.4 or 2.40, both are same. Equal to 2.40 or 2.4, both are same. Now see the next one. 7x minus 9 is equal to 16. So first I want x value. So 7x I am keeping in my LHS side. 16, this minus 9 I am sending to RHS, so it becomes plus 9. So 7x is equal to 16 plus 9, 25. Now I want only x value. The 7 also I am sending to RHS. Here the 7 is in multiplication. When we are sending to RHS, it becomes division. That is nothing but 25 divided by 7, or we can write as 25 by 7. So like this we will solve the problems. Hope you understand. If you understand this, like, share and subscribe to my channel. Thank you.